Hi guys, John the Quant here. This video is the first in a series designed for complete beginners. And this series is modeled on a free data science bootcamp that I guide at the Community College of Aurora in Aurora, Colorado. If you follow along in the series and do the assignments, you should be in a good position to perform some personal projects or maybe try to get a data science internship. As the title of this video suggests, it is intended for you to watch one or maybe two videos a week and then complete a corresponding mini project. Now, this week's mini project is linked in the description box below. But the great thing about doing this online is that you can do it as fast or as slow as you want to. This is where you should be starting. Let's dive in. Data science is a way to generate information. That's what data scientists do. They generate new information. The value that a data scientist creates for the organization is the value of the information the data scientists generate. I did a special video on this, which is linked below as Deeper Video 1, Creating Value with Information. You can watch that later if you want. So, how does data science generate information? Well, data itself is information, and the kind of information varies, but data is just information. In the mini project for this week, the data is information on female patients who may or may not have diabetes. The information is things like how many pregnancies they've had, or their blood pressure, or BMI, or age, or whatever. Now, through statistics, we can use that information, the information we already have, to generate new information on indicators for diabetes. So does blood pressure matter for diabetes diagnosis? And if so, what is the relationship between blood pressure and diabetes? I mean, what are the optimum blood pressure or BMI to avoid diabetes? And these are just three examples of the kinds of questions that data scientists answer. And we're going to see a lot more throughout the series. But really, how do data scientists generate information? Well, like any other scientists, data scientists do research. We use statistics to answer questions. And we'll get into the details of how to use statistics to answer questions in later videos, but for now, just recognize that everything data scientists do, all the machine learning and all the AI and all of that stuff, all of it is a method of answering questions with statistics. If anyone asks you what data scientists do, you can tell them that data scientists help business by using statistics to generate actionable, relevant, and accurate information. You can learn a bit more about what makes information useful for businesses by watching Deeper Video 2, Creating Value with Metrics. Now let's get into the tools of the trade. Data scientists use computers, and they often do their own programming. Software exists that data scientists can use without programming, but most data scientists do their own programming. We're not going to go into that software in this series, but if you are interested, you can check out links below to Amazon Web Services, Microsoft Azure, and Google Cloud Platform courses on their code-free offerings. And like the majority of data scientists, we are going to do our own coding in this program. The first most important tool we are going to use is Python. Python is a fairly simple programming language. It's open source, which means it is free to use. Installing it is easy. I recommend the Anaconda distribution. It's great for data science. In fact, let's go download it and install it together. All right, we are downloading the Anaconda distribution of Python. It's the best one for data science, in my opinion. So we are at www.anaconda.com. All right, then up at the top right here, you're going to click on Free Download. You're going to enter your email address. I actually just did this, so it's not going to work the same for me. But when you click Submit, it's going to send you an email. You're going to go check your email, click on the link, and show up on this page. Now, it should automatically detect the correct version for your operating system, for your computer. Mine, I have a Windows computer that I'm working on, so mine pops up with Windows. But if it doesn't automatically pop up with the right version, then you can select the one that you want. Now, if you have a Mac and you're not sure if you need the Apple Silicon version or the Intel chip version, then what you need to do is go to About This Mac And then under either chip or processor, depending on what version of the OS you're running, it'll tell you, this is an Apple processor or an Intel processor. And then you select the one that you want, and we're going to go with graphical installer there. But it should pop up automatically, and you hit download. It'll take a little bit to download. It's kind of a big file. All right, when it's done downloading, go ahead and click Open File. The installer will pop up, and we're just going to follow, agree, just do everything the normal way. Go ahead and do all the recommended stuff. Now, while this is going, we're going to make a GitHub account. So go over here to github.com. I'm already signed in. So GitHub is a free cloud repository service that most companies use for version control. Now, all of these words might sound complicated, but we're just going to use GitHub to save our files in the cloud where we can access them from any computer and we can share them easily. And if we make a mistake, GitHub gives us an easy way to undo it. That's it. Very simple. Just create an account on github.com. The next thing we're going to want is an IDE, which is an integrated development environment. Now, I like PyCharm, so that is the one we are going to use. It's kind of like Microsoft Word for programming. All right, it's going to give us a place to write our scripts that is designed specifically for script writing. Now, let's head on over to jetbrains.com/PyCharm and scroll down to the bottom of the page. Download here. And then we want the Community Edition. It's going to have to download as well. Let's check on Anaconda. It's still going. We'll just give it a little more time. Alright, Anaconda looks like it is finally done. Go ahead and click Next. We're going to finish this. Now the welcome page should open up. It opened up on my other window, but I don't really care about it, so I'm going to close it. What we want to do next is install PyCharm. Should be done downloading. It's a lot smaller, I think, than Anaconda. I need administrator permission to install PyCharm. And it pops up like this. Oh, don't get canceled. There we go. I'm going to create a desktop shortcut and a .py association. That's it. And let that install. While that's going, let's look at the Anaconda Navigator. So this is the Anaconda Navigator. It holds just a whole bunch of Anaconda stuff. So it can show you, like here, it wants you to install PyCharm Professional. We are already installing PyCharm, the Community Edition. It has just a whole bunch of different stuff. You might be interested in trying some of it out. Jupyter Notebooks, which we are going to work with soon. PowerShell Prompt, which is a pretty great terminal. Here's PyCharm Community that we're installing right now. I've never even used some of these. RStudio is another version. We're using Python, but R is another programming language that's used by data scientists a lot. There's a lot of great stuff here, and you might look into downloading some of it. Hey, alright, PyCharm is finally done. I want to run it immediately. And PyCharm will pop up looking like this. And we don't have anything yet, so we're going to say new project. Right now we just need a Python project. We're going to use base conda. Okay, well let's call this Bootcamp Week 1. And we'll put it in, I'm just going to leave it here and leave it in base conda. I do not want to create a new repository, but you might consider it. The important thing is base conda. This is going to create a new conda environment for us. When you hit create, it's going to make this. Here's our folder. This is all good. All right. So let's connect our GitHub account. So in here, click this thing. We're going to File. There we go. File, Settings. Down to Version Control, GitHub. Here we're going to we're going to log in via GitHub. It's going to go ahead and connect. This is popping up in my other screen. It'll pop up on maybe your same screen. Click Authorize in GitHub and then continue. You should be logged in already. And we're going to authorize JetBrains. Now, I'm not showing you all this because, I don't want you guys to see my password. Cool. And there it is. Now we're showing up. We can now connect to our GitHub super easily. The next thing we need is to make sure that we have a fresh Conda environment. So down here, we're going to go to this thing that says terminal. It's loading for a minute. Now you see where this says base? We don't want it to say base. This should be the name of our environment. So we need to make a new one. Now what an environment means is that we want to keep all the stuff for each project separate from other projects. This is going to help us keep track of what we're doing, and it's going to help make sure our scripts work every time. Basically, each time we work on a new thing, we want to start fresh. We need a new project from PyCharm to keep our files separated. We want to create a new GitHub repository to keep our files separate in the cloud, and we want to create a new Conda environment to keep all of the dependencies separate. Dependencies is actually our next topic. So Python is really cool, right, on its own, but when we add extra software packages, we can do really amazing things incredibly easily. Python comes with a tool called pip that can be used to install all kinds of packages. However, since we are using Conda to handle the programming environment, we should also use Conda to handle packages as much as possible. So let's install a few important ones now. Here in PyCharm, we are in the terminal. Now, you should see the name of the environment down here in parentheses. It just says base right now. So we are going to type conda create -in, and we'll give it a name. How about Bootcamp Week 1? That's running. It can take a little bit sometimes. Say yes. Great. So now we need to do conda activate Bootcamp Week 1 that we just made. And there. Now, see down here where it says Bootcamp Week 1? That's what we want. The first package we're going to install is called NumPy. The NumPy package, it does a whole bunch of math stuff really well, especially linear algebra. We may not use it directly very often in this series, but it's a big, important package that you need to know about. So you can find a link to the documentation in the description below. Documentation is a great way to learn about packages and functions and all kinds of stuff. Now to install NumPy, we're going to type conda install NumPy and hit enter. Now when it asks, you want to say Y and hit enter and just let conda handle the rest. Great. The next package we need to install is pandas. The pandas package is going to help us load data files like CSV and Excel files super easy. It also lets us work with the data in Python and a data frame object, which is super helpful. And we'll see what all that means a little bit later. To install this one, we're going to type conda install pandas and hit enter. And hit Y when that pops up. Alright, just two left. The next one is called matplotlib. And this package is going to let us make graphs. Now graphs are very important for any kind of quantitative professional, and we're going to be making a lot of graphs throughout the series. For now, matplotlib is what we're going to use, and we'll see more packages later. I want you to figure out how to install this one on your own. Great, hopefully you figured out that it was conda install matplotlib. Conda install matplotlib. So the last thing that we want to install right now is Jupyter. And this package does a ton of stuff, but most importantly, it's going to let us use Jupyter notebooks. All of our mini projects throughout this series are going to be done in Jupyter notebooks. It's a lot easier to just show you rather than tell you what they do. So go ahead and install the Jupyter package. All right, are you guys ready? Let's open a Jupyter notebook. All you have to do is type in Jupyter notebook in the terminal there and hit enter, and one will pop up in your browser. There it is. It feels cool, right? We haven't even done anything yet. All right, before we get anything else done, you can see I've already got a couple, but you won't have anything here right now probably. So before you can do anything else, you need to add a new notebook. You go to new and then notebook. And it should pop up like this. Leave that as Python 3, ipykernel, hit select. Let's change the name. Click up here to change the name, and let's just call it, I don't know, week 1. Alright, so now, over here, refresh for a second. There it goes. You should have a notebook called Week 1. And then, as you can see on this, we've got a bunch of different buttons. Don't worry about them right now. What we're worried about is this bar. Actually, before we get any deeper, let's go get some data. So the data that we're working with is the diabetes data set. It is in the Week 1 Google Drive folder in the link below. Now, I've already got it. You want to download it, and you want to put it in this folder. I've already done that. But if you haven't, click on the link. That should download it. And then the folder that you want to put it in, you go back to PyCharm and scroll up. You can see here this line. So it's C users John R Week 1 project. So if I didn't have the diabetes dataset already, I would download it, then go to downloads, copy the file from here. This is on Windows. They're all pretty similar. Go down to local disk C, and then users. See, users. Then John R. There we go. Then Week 1 project right there. And paste it into this folder. And this is just going to make it really easy for you to access the data when you need to. Let's go back to the Jupyter Notebook now. All right, we're ready for some programming. This first cell is important. We want to remember what we are doing here. So almost every Jupyter Notebook I work with starts with exactly the same cell. And in this one, we put import pandas as PD, import numpy as np. Sorry, I've got a sticky in key. And import matplotlib.pyplot as plt. Now you should recognize those because we downloaded them together. Sorry, I have Grammarly installed on my computer. All right, this is going to let us to use the pandas package to load data. It's going to let us use the numpy package for some math and working with data, and it's going to let us use the matplotlib.pyplot package to make charts. In this next cell, I'm going to click here. I'm going to change it to Markdown. See how that went away? That tells you you're in Markdown. Now Markdown is going to let us write and do things like a word processor. So here we're going to give this a title. I am going to call it Week 1. How's that? So this hashtag or # at the front tells it that this is the title. And you can hit Shift Enter or Command Enter on Mac to run that cell, and it'll look nice like that. Now you can do subheadings. Sorry, let's change this one also to Markdown. You can do subheadings by using more of those hashtags. So 2 tells it that it's one step below the title. And you're going to want to, you could put these both in the same cell, but I prefer to keep them separate as separate chunks. Now I've already done this assignment, so I am going to switch over to the one that I've completed, okay? But yours should look like this for now. All right, so I said beginning Python. Notice how there are 2 little hashtags there telling it that it is one step below the title. And I said here we're going to practice a little bit of basic Python and see a few object types that will be important later. There are no hashtags here because this is regular text. See? This one has 3, is a step below that one. Assigning a variable. So assigning a variable is super important, but it's also super easy. Now you just give it a name and have it equal to the value that you want it to have. We're going to do this so much that it's like almost not worth talking about, but the important thing is to always give variables a descriptive name. So here we've got a variable called first_variable. Now variables can start with any letter, or they can start with an underscore, but they cannot start with a number. So first_variable equals 5. If you run this one, then in the next one, you can just type in first variable and it will return 5. See how that goes? Now, just doing arithmetic is super easy as well. It just kind of works the way you would expect. So you can add by just doing the addition symbol. 8 plus 5, and when you run that, it will return 13. Or you can add 8 plus first variable, and remember what our first variable was, it was 5 up here. So when we run this, it is going to do 8 plus the first variable 5. 8 plus 5 is going to return 13 again. See? 13. Or you can overwrite a variable like this. So
Now here we've got our first variable again is equal to 8 plus the first variable. So what this is going to do is it's going to take 8 plus 5, and then it's going to save that as the first variable. So 8 plus 5 is 13. And then the next time we call the first variable, like in this cell, it's going to return 13. See? You can do the same thing with subtraction, just using the subtraction sign here. So I've called this second variable is equal to 25 minus 10. What is that, 15? So whenever I run this, this first line is going to do 25 minus 10 is 15. It's going to save that with the name second variable, and then the second line is just going to call the second variable and print it out. So it's going to say 15 underneath, see? You can multiply by using the asterisk symbol. So this time we're just doing the second variable, which is 15 times 3, and then printing it out underneath. So that's going to print 45 when you run that. You can also divide. Now there are different kinds of division. This is just regular division, and we'll talk a little bit about the difference and why the difference is important. So here we're dividing, and we're going to overwrite the name second variable. So this line is going to take the second variable here, which is 15, divided by 5, which is 3, right? And it's going to save it with the name second variable. So it's going to do 15 divided by 5 is 3, and save that as second variable. So now when we run this next cell that just calls out the second variable, it should give us a 3. There goes 3. But notice how up here it's 45, up here it's 15. There's no decimal, and here it is a decimal. And that's because we used this kind of divide with only a single slash. If you want to get rid of the decimal, you do double slash like this. Slash slash tells it to return an integer instead of a floating point number. So when you run this one and then the next one, you gotta go all the way back. Now it's going to return 3 with no decimals. There it goes. So why did that not work a second ago? Well, it didn't work because I had already overwritten the second variable. So when I was doing it the second time, the first time it did second variable equals 15 from this cell up here, divided by 5, which is 3, and then overwrote it. So the second time I tried to run this cell, it did the second variable is equal to 3 divided by 5, which is a decimal point. It's less than 1, so when you get the integer of that out, it returns 0. Now, you can, in a Jupyter notebook like this, you can return a variable by just typing it, or in the next one, you have to use print. So when you use a print statement, it'll print it. So here you can make it print multiple things in the same cell. You can do print second variable, and then you can change the second variable, and then you can print it again. So let's see the second one. It's going to be 3 times 15 is 45, and then divided by 3 again to get us back to 15. And when you print it, it prints 3, then 15. Now notice how it has the decimal point on there because we did a regular divide here. The next thing we look to look at is a list. Now a list is an ordered sequence of objects. They can be any number of strings or words or variables or whatever. Or you can even include more complicated objects like data frames and arrays and models, which we will talk about later. But it's just an ordered sequence of anything you want. So here we've got one called test list 1, which is equal to 0, 1, 2, 3. The way you tell Python that it's a list is you put the square brackets on either end and then a comma separating the values. So when we print this off, it's going to tell us square brackets 0, 1, 2, 3. Or we can do it with strings here, A, B, C, D. Notice how it has these square brackets again. Now, here I made a third variable, which is the word third. And then I've created a list with the square brackets that has our first variable, our second variable, and our third variable in it. So this is a list of variables, and then I'm printing the list at the end. So see, our first variable is 13, second variable is 15, and the third variable is the word third. And you can get an element out of a list by using its place in the list. So in Python, places start at 0. So first, here we're going to print the whole list, which again is 13, 15.0, and then the word third. Now this next one, after calling the list, we have a square bracket and the number 0. So this tells us to get the 0th position in the list, which is the number 13 here. And the next line is the first position, which is the number 15.0. And the second one is this last position, which is the word third. So here it's going to print the whole list, and then it's going to print 13, 15.0, and third, which is exactly what it does. A dictionary is kind of like a list in that you can have a collection of objects, and they can be any kind of object that you want, but it doesn't necessarily have an order. So in a list, right, they were in order, and we could go 0, 1, 2 to call them out. But a dictionary doesn't have that. Instead, it has a key value pair. So the key here is this. The key here is that. The key here is the other. So when you're making this, you do dictionary, and then you assign it with equals, and you use the curly brackets to tell it that it's a dictionary. Then you have to give it has to be a string, it has to be a word, so you have to put it in quotes. All right, and then you do a colon, and then the value. So this is the key, and 1 is the value. That is the key, and 2 is the value. The other is the key, and 3 is the value. So here's what it looks like if you just print a dictionary. Just kind of shows you the whole thing, right? And if you want to pull something out, you have to call it by the key. So here we have testdict1, right, which has these keys and values in it, and then we're using these square brackets and the word this to pull out this value, which is 1. There you go, pulls out 1. Now we can assign that from the dictionary to its own variable. So whenever we use this, it's going to pull the value 2 out of the dictionary and assign it to a variable which we call that. So when I print that, it prints a 2. Then we can add elements of the dictionary together by accessing them, the normal way. So we've got the text dictionary, square brackets, and we're adding this, which is 1, and over here that, which is 2. So in this line, what we're doing is 1 plus 2, which is 3. There it goes. So in this cell, we're subtracting an element of a dictionary from an element from a list. So we're going to get the second place of our test list 1, which test list 1 was 0, 1, 2, 3, so the second place is a 2. And then we're going to print that value of our test dictionary, which was up here, hold on, also a 2, up there. And then we're going to say, if we subtract the 2, ... and down here we're going to subtract them. All right, test list, second place, minus test dictionary, that. So we're doing 2 minus 2, which would give us a 0. And there it goes, 2 minus 2, if we subtract the 2, 0. Now there are a lot more Python objects that you're going to need to practice and get familiar with, and there are more ways to work with the objects that we've seen, so you really should learn more and practice more and get better at basic Python. And there are a lot of online tools for free to help you do this. I recommend this one here, www.learnpython.org. There will be a link in the description to this video, or you can access that through the notebook that I will attach as well. Now let's actually load some data. All right, the first step in any analysis is to load the data. So in our data is a CSV file, which is a very common situation. Data is also in our working directory, right here. You can see that. And if you're not sure if it's in the working directory, what you can do is create a new code cell, put an exclamation point and do ls, and then run that. Sorry, it's ls on Linux, or Mac it is dir in Windows. So you run that, and it'll tell you everything in your working directory. So what we're looking for is this one, diabetesdata.csv. Make sure that's in there. And we're going to load the CSV file using pandas. It's the easiest way to work with this. So here we've got data, assigning the variable is equal to PD. This tells Python that we're working in the pandas package, dot read_CSV. So this here, pd.readCSV, tells Python that the read CSV function is inside the pandas package. open parentheses, and then the path to our file. Since it's in the working directory, it's just the name of the file in quotes. So diabetes_data.csv, close quotes, close parentheses, and run that. And now it will be saved in a variable called data. So you can just look at the data. There you go. So what it looks like, we've got pregnancies, glucose, blood pressure, skin thickness. These are the names of the different health factors that we know about. And then outcome here is whether or not each patient has been diagnosed with diabetes. Down at the bottom, you can see there's 9 columns, 768 rows, and each row is a patient. So this is 768 patients, and we have 9 pieces of information about each patient. But let's just look at the top 10. To look at the top, however many you do, is data.head. So in this case, data.head, 10. By default, it shows 5, but here we're looking at 10. So this is just going to show us the top 10 rows. To look at the bottom, you use .tail, and by default it shows 5, but here we're looking at 7, so we've got data.tail 7. Shows us the bottom 7 rows. You can look at the names of the columns by using data.columns. I've wrapped it in print here, but you don't have to. It shows you an index with these columns. And of course you have an index, which is this one over on the left, which you can see is going to go from 0 here all the way to 767, or 768, excuse me. So when you look at the data.index, start at 0, stop at 768, step by ones. So that tells us it's going to go 1, 2, 3, 4, 5, 6, all the way up to 768. But it stops 1 early because the first one is 0. You can change the names of the columns, which is something you probably have to do a lot, using data.rename. So here we're going to make them lowercase, all right? We're going to overwrite the data variable by doing data equals. Then we're going to use data.rename, open parentheses. Now this is str.lower, string.lower. This is a function that takes anything in quotes, any words or whatever, and just makes them all lowercase. And then access equals columns. So we're taking all of the columns here and making them lower, and then we're saving that as the variable data. So if we do it again and look at the top 5 with data.head, you can see we've taken all of these columns from before that had capital letters in them and just made them all lowercase. It's a lot easier if you don't have to keep remembering when to capitalize. So I always recommend you just make them all lowercase. Or you can change them entirely. So this first line, data2 equals data.copy. .copy tells it to create an entirely separate copy of the data frame. Python's a little weird sometimes, so if you need to make changes that you're not certain about, I recommend that you use .copy most of the time. So we got data.copy, and we're saving that as the variable data2. So we have a new variable, data2. And you can say data2.columns, okay, equal, and then we've got a list here. Now, when you do this, your list has to be the same length as the number of columns you have. So I've just shortened them all. Instead of pregnancies, I named it preg. Instead of glucose, I named it sugar. Instead of pressure, blood pressure, I named it pressure, and so on. Then we'll look at the top 5 rows of that. See, and this might be just easier for you to look at than the previous one. But there's really no need to do this. So we're not going to work with data2 anymore. We're just going to work with data the whole time. So to pull out a single column, data frames kind of work like dictionaries. So we had a column named BMI right here, this column. So to pull that one out, we're just going to use data, square brackets, open quotes, BMI, close quotes, close brackets, run that, and it only returns that column. You can also do arithmetic with the columns. So here we're adding the glucose column to the BMI column. So like the first one is going to be 148 plus 33.6. What is that? 181.6. And you just add them together, 181.6, good. And it will return a column of each individual row added together. You can divide as well. Here we're dividing pregnancies by age. And you can make a new column by assigning it a value. So here we've got data, open parentheses, open the brackets, there we go. And we're creating a new column called pregnancies underscore per underscore year, pregnancies per year, which is equal to the number of pregnancies in the pregnancies column divided by the age in the age column. So this is going to take the numbers, each individual number in the pregnancies column, divided by each row in the age column, and then save that to a new column called pregnancies per year. Let's go ahead and run that, and it spits out right here pregnancies per year, just like we wanted it to. You can also go by rows instead of columns. So by rows is a little more complicated, honestly, but it's not too hard. So here we're doing a simple filter. We're going to filter based on row values. So this one will return only rows that have had a pregnancy. So we've got, sorry, this is a little more complicated. It's data, and then you open a square bracket, and then data, open a square bracket again. Pregnancies, close the first bracket, is greater than 0. So this, on the inside, let's look at what's happening on the inside. So if you get rid of the outer one, we've got data, pregnancies, the pregnancies column, greater than 0. So if you run that, it's going to return true, 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 false, and so on. Okay? But if you do data and then you wrap that in these square brackets, every row that is true is going to get returned, and if it's false, it's just not going to exist anymore. See? We started with 768 rows, but now we only have 657 because we got rid of all of the ones that had 0 pregnancies. Or if you want to keep exact matches, you would do the same thing, but instead of greater than, use double equals. So here, we're going to go through the age column, get all of the ages that are equal to 34, and then only return those rows. So in our final product, the only rows will have age equal 34. Where's age? There we go. And they are all 34, exactly what we wanted. Now, you can get specific rows using the .loc, method. So we've got data.loc, then we're opening the brackets, and then we have a colon and the number 10, comma, and then a colon. So this first thing inside the square brackets, all right, first loc tells Python that we're going to look through the data frame. Then this one here, the colon 10, tells us to go from 0 to 10 in the rows. And then this colon says to just get all of the columns. So when we run this, it's going to go through the data frame. It's going to get the first 10 rows, any row with an index less than 10, and it's going to get all the columns. So we run that, we get everything with an index less than or equal to 10, but we get all of the columns. But say we didn't want all the columns. Let's say we wanted to get all the rows, but we only wanted the pregnancies and glucose columns. Well, in that case, we would do .loc, open square brackets, use a colon to get all rows, then a comma, and then after the comma, we have a list of columns that we want. So our list here has pregnancies and glucose. Finish the list and close the brackets and run that. You can see it returned all 768 rows of just the pregnancies and glucose columns. So you can do a lot of different filtering, and you're going to practice doing this an awful lot. So don't worry if it's kind of hard right now. You'll get used to it really quickly. So in this one, we're getting rows where the age is equal to 34, but we're only getting the BMI and outcome columns. Okay, so we're filtering 2 times. First, we're filtering for age equals 34, and then we're filtering only the BMI and outcome columns. So we run that, we just get a few. We don't get to see their age because we didn't return it, but all of these people have age equals 34. All right, we're doing a complicated new column. This one says, we're going to create a column that explicitly says whether or not a person has diabetes. So let's make one. So first we're going to call it diabetes. So we're assigning a new column, and we're going to set everything equal to the word no. All right, and just run that and get the head, check it out. It has no in every column so far. Now we're going to go back through that diabetes column, and everywhere that outcome is equal to 1, remember outcome equals 1 means that this person has diabetes. So in every row where outcome is equal to 1, we're going to change the value in the diabetes column to be yes. So look for rows where outcome is equal to 1, find the diabetes column, and have it set it equal to yes. So when we look at that, now we can see that if outcome is 1, diabetes is yes. Outcome is no, diabetes is no. Outcome is 1, diabetes is yes. Outcome is 0, diabetes is no. Outcome is 1, diabetes is yes. So we've created this kind of complex new column, and I know that this one contains exactly the same information as the outcome column, but it usually won't. And we've created this entirely new column by sequentially or iteratively overwriting some of the values. This is very helpful. We could do both of those at once in the same cell. By doing it like this, create a new column called diabetes, have it equal no, and then go through the full data frame where the outcome is equal to 1, find the diabetes column, and change it to yes. You could just do it all at once instead of doing it as 2 separate steps like I did before. All right, we need to talk about data types because people get caught up in data types a lot. For functions to work, Python needs to know what type of data is. For example, it needs to know that numbers are numbers, or that words are words, or that dates are dates, and so on. And this will make sense as we keep going through the series. So what you can use to check this out is data.info. And info is going to print off this little thing. It's going to tell you each column. It'll give you an idea of the range, of the index, how many values are actually missing in that column. We're not missing any values here. And then d-type. So pregnancies is an integer. Glucose is an integer. Integer down to BMI, which is a floating point number. Age is an integer. Pregnancies per year is a floating number. And then diabetes is an object. Object just means it's a string, it's a word, it's something that's not a number. Pandas is usually pretty good at guessing what type of column should have, but we can change it if we want. And you usually have to change dates on your own. They usually don't get brought in as dates. And we'll see that a lot later on. So let's change the glucose column to float. Right now, glucose is an integer. Int 64 is a type of integer. So to change it to a float, we are going to get that column by doing data brackets glucose close brackets dot as type, okay, and then in quotes float. So this says get the glucose column, but get it as type float. So when you run that, it's going to have 0.0, and then down here it's going to say float 64. See, it used to say int 64, and up here they used to not have zeros. Now it has zeros, and it says float 64. This might seem pedantic, but it is important when we come up to modeling later. It's going to make a big difference when we try to actually build models. Then we're going to change the outcome column to a Boolean. Boolean means it's either true or false. Now remember, our outcome column here is ones and zeros, which are integers, whole numbers. Here it's an integer. Here it's ones and zeros. What we're going to do, data, get the outcome column, dot as type bool, B-O-O-L, and that's going to change it to true and false. There you go, true, false, true, false, true, false was false, true, false. Type is bool. You can also look directly at the dtypes of a data frame by doing data.dtypes. There you go. This is kind of like the info section, except it only returns the dtypes for each column. So now we're going to do change the outcome, reassign the outcome to the Boolean version of itself. So we're taking the outcome column and we're overwriting it with the outcome column as type Boolean. And then look at the head of that, and you've changed it inside the data frame. True, false, true, false, true, instead of 1001. we can change it back actually. So um, data outcome and override it with outcome as type. I used int 8. This number after, this tells it it's an integer and use 64 bits. So the bigger this number on the outside is, the more computer memory this number is allowed to take up. Usually you want to just leave it as big as possible. 64 is good. 32 is okay. When you start getting down to 16, then you do start running into problems. So I would just leave it as whatever it comes with. But here I'm changing it to 8. And the reason for that is because in computer memory, the Boolean type is like the smallest possible type, but it's actually the same as this int 8. They're both very small, take up barely any computer space. And if you have zeros and ones, like that's all you need. So here, we've changed it back to zeros and ones on the output. Let's play a bit with NumPy. All right, one of the most important things that NumPy gives us is an array object. You can think of an array as like a matrix that can have as many dimensions as we want. It's kind of like a tensor, I guess, if you guys are engineers. Except NumPy arrays can have any data type. To understand what I mean, we're going to look real quickly at different ways of structuring data in Python, and I promise it is not as complicated as it sounds. So here's a single number, 5. You run that, you get 5. Here is a one-dimensional list. You run that, you get one-dimensional list, 0, 1, 2, 3. Now let's make it two-dimensional with a NumPy array, np.array. The array function is inside the NumPy package. Open the parentheses, and then you see how it looks like we have a list with two lists inside it? So each one of these sublists, 0, 1, and 2, 3, is a dimension of the array. So when we run this and it prints it out, it's going to look like a little 2 by 2 matrix here. 0, 1, 2, 3. Cool, right? Now let's try a 3-dimensional array, which if we do anything with images or videos, facial recognition, computer vision, any of that stuff, you do use 3-dimensional arrays a lot. Most other data is 2-dimensional, but images and videos are at least 3 dimensions. So here, np.array, okay, the array function is inside the NumPy package. Then we have 3 open brackets. Okay, the innermost one is a dimension. The second one is also a dimension. And then the third one is a dimension. This sounds complicated, and you might think, man, this is overwhelming right now, but you will almost never have to do this by hand, so don't worry too much. This is just to show you how it works, all right? So when we run this, we can't actually see in 3 dimensions, so it gives us this 2-dimensional representation where we have one dimension is like 0, 1, 2, 3, 4, 5. The second dimension is like that batch of things, and then the third dimension is the full list. So when we assign that to say ARR, so then we now have a variable ARR which is equal to this 3-dimensional NumPy array, we can call ARR.shape, SHAPE, that tells us how far the data goes in each dimension. So when we run this, we can see that it's 3-dimensional. We have, say, 1 row, 3 columns, and 2 depth. And that's the shape of this array here. So shape matters when you need to use 2 arrays at the same time, like if you're adding or like subtracting or doing any kind of arithmetic really, or like when joining arrays together to make one big array, or when using them as input to a model, it comes up a lot. So most models work well with data frames nowadays, but there are a few times when it's actually better to use a NumPy array instead. Speaking of which, actually, Pandas data frames are arrays underneath. So we have our data frame dot values. When you run this, it reveals that it's really a NumPy array underneath. So we can look at the dot shape of that. Data.values.shape, 768 rows, and 11 columns, exactly the same as the data frame. You can slice NumPy arrays, but they don't have column names or row indexing, so you just use numbers only. Let's check that out. So we have here pregnancies is the 0th column. You can see data.columns in the 0th place returns pregnancies. So in pandas, if we wanted to get the top 5 rows of the pregnancies column, we would use data, open brackets, pregnancies dot head. I did double brackets here so that it would return a data frame just to make it look nice. Don't worry too much about that. But in NumPy, we would get data.values, and we would need the 0th column, which we said was pregnancies up here, and we would need :5, the first 5 values of the 0th column, whereas here we used data pregnancies.head. But they return the same values, 61810 versus in NumPy 61810. So these are exactly the same thing, they just look different. And anytime you're working with data, all right, all the models and functions and whatever, they're all going to have an expected data shape. And most of the time, it is as simple as having a data frame as the X input and a single column as the Y output. But sometimes it does get a little more complicated. So when your data is the wrong shape, function won't work. I run into it most often when using like scikit-learn, which we will learn about next week a little bit. And scikit-learn takes in pandas data frames, but outputs NumPy arrays. So let's look at how to reshape the data. So here, data frame shape is 768 by 11, and the array shape is the same. The array is just data.values. So they're the same data. One's in a pandas data frame, one is in a NumPy array. So the total number of values in our data frame is 8,448. Okay, 768 rows times 11 columns equals 8,448 total values. So the new shape has to have the same number of values. So to reshape it, we use arr array dot reshape, and then tell it what new shape to do. So here we're doing, what is this, 8,448 divided by 4. It needs to be an integer here. This many rows and 4 columns. Now this new data frame, this new array is not going to make any sense. We're just showing that you can reshape things, okay? So the new array is equal to the old array reshaped to be whatever 8,448 divided by 4 is, rows and 4 columns. So then we'll see the new shape, and then we'll have a look at the new array. The new shape is 2,112 rows and 4 columns. And the new array looks like this. Here's your 4 columns, here's your next 4 columns, here's your next 4 columns, and so on. Of course, again, it doesn't make any sense. This new array is not useful. We're just looking at how to reshape arrays. So let's try one that has 192 columns. Why not? So the new array here is being assigned to the old array.reshape, 8,448, that's the total number of values we used to have, divided by 192, and then we're going to have 192 columns. So the new shape is 192 columns and only 44 rows, and it looks like this. You can't really see because there's 192 columns, it doesn't have space to print that out, and there's 44 rows, we don't have space to print that out. Now the next one is the same array, it's just going to be flipped. So like columns are rows and rows are columns. And this comes up a lot when you're using time series like in music or videos. So to flip it so that columns are rows and rows are columns, it's just dot and then capital T. That dot capital T means transpose. So the new array now is the original array with the rows and columns flipped. So the original array had shape 768 by 11. Let's check on that. Yep, 768 by 11. So the new one will have 11 rows, 768 columns. So we'll run this one. 11 rows, 768 columns. And the new array is the same as the old array, just flipped, where this used to be a row and now it's a column. You can do that with data frames too. All right, the original data frame had 0, 1, 2, and so on as the rows, and it had the column names as the columns, but when we do data dot capital T for transpose, we now have the column names as rows and the row index as column names. Let's do some more in Pandas, because Pandas is awesome and it makes a lot of things like super easy. This is really just a small taste. All right, to really get into it, you got to go to the Pandas course that I've linked to below. So the first thing we're going to do is calculate the mean or the average of every column. All right, so data.mean, M-E-A-N, open parentheses. Then here, numeric only equals true with capital T. This is new, and it's kind of annoying, but this tells it to only try to calculate the average of the numeric columns. So our diabetes column that says yes or no, you can't add, there's no average of words. So if you try it without numeric only equals true, then this will not work. But if you run that, it will calculate the average for every single row. So the average number of pregnancies is 3.84. The average glucose meeting is 120.89, and so on. If you wanted to calculate the mean of one column at a time, you would just get that column and do dot mean. So we're going to get the age column and then dot mean to find the average there, which is 33.24. It should be the same up here, 33.24, yep. You can also get the standard deviation of all the numeric columns. It's okay if you don't know what standard deviation and mean are right now. We are going to talk about them a lot next week. We're just showing you how to calculate them real quick. So standard deviation, you do the data.std. You still need that numeric only equals true, and this tells you the standard deviation of all the columns very, very quickly. You can get the maximum value of the columns with .max. You still need that numeric only equals true. Maximum value of every single column. Or you can just get like all that information at the same time with data.describe. Describe is a good one that you're probably going to want to use almost every time, because that tells you how many values there are in each column. It tells you what the mean of each column is. It tells you the standard deviation of the column. It gives you the minimum value, the 25th percentile, the median, or 50th percentile, the 75th percentile, and the maximum. Now don't worry about the word percentile or median or mean or standard deviation. This is what next week is actually all about. But you can get all of that information, so much information, that we're going to be working with next week with .describe. It's just that easy. You can get a covariance matrix, and again, don't worry about what covariance means. Basically, it just means like how how connected are two columns. Okay, so .cov, again, you need numeric only equals true, and that will give you an idea of how connected different columns are. So like here, 13.95 tells us that the pregnancies and glucose columns are kind of connected, or the pregnancies and insulin columns with -28, they seem pretty connected as well, even though it's in the opposite direction. But don't worry too much about covariance. That is something we're going to talk a lot about in a couple of weeks. This is just how to pull that up very quickly using Pandas. Do the same thing with correlation. The correlation is the same as covariance, except that on the diagonal everything is 1, so you're just kind of like dividing by a certain number that makes everything on the diagonal turn to 1. Again, this is a measure of how connected two variables are, and don't worry too much about it, because we are going to talk a lot about this in the coming weeks. This is just how to calculate it very quickly using Pandas. So to get the correlation matrix, you do data.corr, C-O-R-R, and you need numeric only equals true, and it'll pull that up. There are like 1,000 things that are super easy to do with Pandas, but these are really the main ones that we're going to use in this series. So I absolutely, definitely encourage you to learn more about Pandas and all of the functionality available. Matplotlib. Let's make some graphs, right? Matplotlib is all about plotting graphs. You might have guessed that from the name, Matplotlib, mathematical plot library, right? It's a very powerful library. We're going to use it a lot, and it is used a lot, all the time. It's not my favorite, and we're soon going to see other graphing libraries that, in my opinion, are both easier and look nicer, but Matplotlib will get you really far, and is absolutely necessary for graphing in Python. The easiest thing you can do is take a data frame, data, dot plot, P-L-O-T. So that's going to use the index for the x-axis, and it's going to plot a line graph for every single column. So we run that, see this here, every single column gets a line on a single graph. Sometimes that's useful, but I mean in this case, I can't really read this, so it's not useful at all. So what we can do to make it a little more useful is data.plot, but keep this parameter, subplots equals true with a capital T. So this is going to plot every single one of them, but separately instead of all together. Plots it separately like this, see? The semicolon on the end here suppresses the output. Did we suppress it on the last one? We did not. See, this is where it says axes. If you do the semicolon, it doesn't say that. That's all it does. So you can plot a single column by pulling that column out of the data. So data skin thickness column dot plot, and that plots a single column in a line chart like this. You can use a scatter plot. This is actually took a big jump forward, all right? So here, matplotlib.pyplot as PLT. Remember that? So we're getting the subplots function out of the matplotlib.pyplot package. We're telling it that the figure should be 8 inches by 5 inches, 8 inches wide and 5 inches tall. Okay, and we're assigning that to fig and ax. And then we're using ax, that comes out of this, dot scatter to make a scatter plot. We're telling it that the x-axis should be the insulin column, the y-axis should be the skin thickness column. Then we're going to do ax dot set label, set x label, set underscore x label, insulin, ax dot set underscore y label, skin thickness, and ax dot set underscore title, relationship between insulin and skin thickness. So here we've created this plot that is 8 inches long, wide, and 5 inches tall. We put the insulin column on the x-axis here. We put the skin thickness column on the y-axis here. Then we gave this a label that says insulin. We gave this a label that says skin thickness. And we gave the whole thing a title, relationship between insulin and skin thickness. This next cell is the same thing, but we're making 4 graphs at the same time. So we're using that same plt.subplots, but this time we have in rows equals 2, okay, 2 rows. In cols equals 2, okay, 2 columns. Fig size equals 20 by 15. So this is going to make 4 graphs, 2 rows and 2 columns. 2 by 2 is 4, with a figure size of 20 inches wide and 15 inches tall. And then it's going through each of these ax 0, 0. So this is the top left plot, the 0th row and the 0th column. We're going to do a scatter plot with insulin on the x-axis and skin thickness on the y-axis. Then we're setting the labels and giving it a title. And then on to the next one. This is the 0th row and the 1st column. So this is the top right. We're going to put BMI on the x-axis and skin thickness on the y-axis and give them labels and titles. Then next we have the 1st row and the 0th column, so that's the bottom left. We're putting BMI on the x-axis, blood pressure on the y-axis, giving them labels and a title. And then lastly, the 1st column and 1st row. That's the bottom right in this case. And on the x-axis, we're going to do pregnancies per year. And on the y-axis, we're doing glucose and just setting the labels. So you can see we made all 4 of these all at once. I think the last thing maybe, no, but almost the last thing we need to cover is for loops. So a for loop makes the code inside it happen over and over again until it reaches the end. Let's see exactly what that means. So the word for here tells Python that we're making a loop. Now I is a temporary variable that only exists inside this loop. In tells us what we're looping over, and then range 5 gives us the numbers 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So here, for I in range 5 tells us to loop through. Okay, I is equal to 0, run all the code below. I is equal to 1, run all the code below. I is equal to 2, run all the code below. I is equal to 3, run all the code below. I is equal to 4, run all the code below. So in our code, we're just printing the next number is I. So it's going to go, when I is 0, the next number is 0. When I is 1, the next number is 1. And so on, all the way to 4. So we run that. It runs the next number is 0, 1, 2, 3, 4. It did exactly what we thought it was going to do. But you don't have to loop over a range. You can loop over any kind of list or index. So here, we're looping through the columns. So we're saying for call, C-O-L, in data.columns, and we're just going to print the name of that column. So what are our columns? They were over here, pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, and so on. And that's what it's going to do. It's going to print the name, pregnancies. When column is equal to pregnancies, run everything below. When column is equal to glucose, run everything below, and so on. So that's just printing all of those out. You can loop through a list, and in this case we're actually going to loop through the list and change the values in the list. So we have for I is our temporary variable, and range, length, test list 1. So here's what we're doing. We're taking test list 1, which had 4 values in it, 0, 1, 2, 3. We're getting the length of that, which is 4. We're doing range over the length. So this, everything that's highlighted right now is going to return 0, 1, 2, 3. And then we're looping through that, calling it I. So I is going to go 0, 1, 2, 3. Here we have test list. We're taking the ith spot. So when I is 0, this is going to be the 0th spot. When I is 1, it'll be the first spot. When I is 2, it'll be the second spot, and so on. And we're replacing that with the sign value of itself. This sounds really complicated. I just want you to look at this line and try to pick apart exactly what each piece is doing. Because this is kind of a normal thing. It is a pretty normal thing to need to loop through something and do some calculation and then save it. Okay, so this is going to go through the range of the entire list, 0, 1, 2, 3. Then it is going to get the spot of that, get the value in that spot, and overwrite it with the sign of itself. So we're going to have I equals 0, and we're going to say the 0th element of the list is equal to the sign of the 0th element in the list. And when I equals 1, we're going to get the first element in the list. It's equal to the sign of the first element in the list, and so on. So when we print that out, instead of test list 1 being 0, 1, 2, 3, we now have sign of 0, which is 0, sign of 1, which I guess is 0.84, I don't know, sign of 2, which is 0.91, sign of 3, which is 0.14. Loops are super important, and we're going to use them a lot, so you do need to know how to work with loops, but you will also learn by doing throughout the course. Next we have logical statements, so that's like, if this is true, then do this, otherwise do that, right? And there's more to it, and we're going to approach more complicated logic as it comes up, but for now, just think about like a single branch that splits into 2 branches. All right, logical statements split the flow into multiple paths. So let's see a few examples. I have a lot of comment in this one because it is the most complicated cell we've seen so far, right? But don't worry, it's pretty simple. This first chunk, okay, for I in range 1000, this says to run this code 1000 times, okay? Run this code 1000 times. And here, x equals input, please type an integer. So what it's going to do is it's going to pop up down like this down here. It's going to say, please type an integer. And then you're going to type something. Okay? And then it's going to try to take whatever you typed in and change it into an integer. So if you type in y, it's going to try to change y into an integer. And if it doesn't work, okay, this except value error means if it doesn't work, then it's going to print, you did not input an integer. And if it does work, then it's going to stop running this loop. So it's going to give you 1000 chances to type in something that it thinks is an integer. And when you do, all it's going to do is, if x is bigger than 3, it's going to say x is more than 3. Otherwise, it's going to say x is less than 3. That's it. So let's run this. Let's try something that's not an integer. I'll type in my name here, John. Oh, it says I did not input an integer. What if I do type in the word 7? Oh, still not an integer. What about 9? There you go. 9 is more than 3. So it says x is more than 3. See? So it looks complicated, but it doesn't really do anything that interesting. And here's another one. This time x is going to be it's going to ask you to type in anything you want. Okay? And then it's going to figure out how long is that thing that you typed. And if it's less than 4 characters long, it's going to say, it's going to print short, you entered 4 or fewer characters. But if it is more than 4 but less than 10, it's going to print medium. You entered more than 4 but less than 10 characters. And the last one, if there's more than 10, it's going to print long. You entered 10 or more characters. Go ahead and try that. I'll type the word short. Short is suspiciously medium length. You entered more than 4 characters with less than 10 because there's 5. Let's try me. Short, you entered 4 or fewer characters. Or this is a long one. That's more than 10 characters, right? So you entered 10 or more characters. That's just a little example of working with logical statements. We're going to do a lot of these as well. I just want you to see them. You don't need to, have them down pat right now. So a function, we need to talk about 3 more things: functions, classes, and methods. So these are 3 things that seem similar but are different in important ways. All right, functions, classes, and methods. I'm going to try to be as specific as possible by referring to things with the proper term. A function is a set of instructions to perform a certain task. A function does one thing and that's it, and it does like one thing and then it goes away, all right? A class is an item. This can get confusing because technically everything in Python is an object, but I want you to think about a class as an item, a thing that you can carry around and use whenever you need it. Okay, classes don't do anything on their own. They're tools that can be used to do things, and most classes can do a lot of things. So once you create a class, it sticks around. A function runs once and goes away. Classes get created and then stay. Now, a method is a function that is performed by a class. So a method does one thing, but it is attached to a class. And these will become second nature, and honestly the difference isn't that important for anything we're going to do in this series. But documentation can be very pedantic, so it's important that you understand the difference between the 3. So here's an example of a function. np.mean is a function. It calculates the mean, and that's all it does. It doesn't stick around after. If you call it without parentheses on the end, it'll tell you it's a function. Now, an example of a class is a data frame, pd.dataFrame. So we have our test list 1, which is a list, which is a different kind of object or class. But if we wrap that in pd.dataFrame, then we can change it from a list to a data frame, which is what I did here. There we go. All right, so it is a list here, and we've turned it into a data frame. So we've changed the class from list to data frame. You can check that, okay, by saying type list, test list. And that'll tell you it's a list. But if we change it to a data frame, then run type pandas.core.frame.dataframe. See? Or if you just type pd.dataframe, it'll tell you exactly where it comes from. pandas.core.frame.dataframe. So when it's a function, it tells you that it's a function. And when it's a class, it tells you where that class comes from. So an example of a method is the data.mean, like we'd used before. .mean is the method. It just calculates the mean, and then it goes away. But it is attached to the data class, the data frame. You can define your own function, and it's super easy. I don't know how much we're going to do it in this series, but it is something you should know how to do. So here's how to do it. Def, D-E-F, for define. Then you need to give it a name. I'm calling this one mean function because it's going to calculate the mean. And then you list your parameters here. Ours is just going to take a list as an input. And then this one, the first thing it's going to do, it's going to get the sum of a list by summing the list. Okay, the Python sum function adds up the elements of a list. Then it's going to get the mean of the list by taking the sum of the list and dividing it by the length of the list. The average is you add up all the numbers and divide by the number of numbers, and that's what we're doing. This line here adds up all the numbers. This line here divides by the number of numbers. And we're going to return the mean of the list. So to get a value out of a function, you need a line that starts with the word return. Return. And then after that word, whatever you want to get as output. So this function here is going to take input list as an input, and it's going to give you back mean of list as an output. So let's check it out. We're going to take our test list 1, put it through our mean function that we just made. So list here, and this is the mean or the average, and it should be the same as it was up here. It is. All right, this is our first little foray into Python. I know there was a lot that we covered today, but I think you guys can handle it. It's important that you get used to using Python, so definitely practice it and make sure you do the mini project. The mini project is actually easier than most of the stuff that we did in this Python lesson. All right, let's go back to in person and talk about the next steps.
Now that's everything you need to know to get started learning Python for data science. The best way to learn is to do more. So we're just going to do a lot of it throughout this series, and there's no need to overwhelm ourselves right now. There is a link to this week's practice project in the description below. This week, you're going to load a diabetes data set. You're going to do some calculations, and then you're going to write a description of the average diabetic versus non-diabetic person. My solution is also available at the link, and I encourage you to make your own solution before you look at mine. But remember, just because I did things a certain way doesn't mean that that's the right way or that that's the best way. Part of this bootcamp is learning to solve problems in your own way, and I am excited to see what you guys come up with. As usual, submit questions in the comments, and you can even post your weekly project down in the comments. I mean, I think it would be beneficial for all of us to see how our colleagues approached the problems. And I cannot get to everyone, but if we all work together, we can answer each other's questions. And you don't have to be 100% knowledgeable to be helpful. If you learned something in this video, give it a like. If you want to keep learning, go ahead and subscribe. This week, we're going to do an introduction to SQL, SQL, Structured Query Language. That is the next video. It should pop up, and I'll see you there.